All right, folks, so let's continue the march on section 7.3, exercise 21 through 32. So, as you could probably hear, I just changed my mic because my other mic was caca. So, hopefully, this one is much better. All right, so we are going to simplify. So, let me write this down. We are going to simplify these radicals. And what I'm going to give you a little hint, we're going to do this by factoring. All right, factoring is a great tool to help us simplify radicals. All right, so let's check it out. Let's get the square root of 27. All right, so what I'm going to do is you're about to receive a text message right about now. Bam, money. And in this text message is going to be a link. All right, it's going to be a link of all our perfect squares, all our perfect cubes, all our perfect fourth powers, our perfect fifth powers. All right, and I'm going to show you how to use that list. All right, so this list, this text message, that link is going to look like this. And notice we are looking at square roots because my index is 2. So write that down. The index is 2. Well, what the heck does that mean? That means that you're going to focus on this list right here because these are all my perfect squares. So this list right here is what you're focusing on. Okay, so I look at that 27, and do you see 27 in this list that we just highlighted? No. So this is the game plan. All right, so here we go. So our game plan, what we do is we break this down into two radicals. Always two radicals. The first one is always going to be a perfect square. And I say square because we're looking at the perfect squares. And this one I call the leftovers. It's going to be remaining, the leftovers, the remaining factor, the remaining factor. All right. So when I look at my list, I say, what's the biggest number here in this list that I could divide 27 by? Boom, 9. So 9 times what is 27? 9 times 3. So whatever is left over, the remaining factor is right there. All right. Any questions so far? Good. No questions. So why? Well, the reason is because what is the square root of 9? Nice. It's just 3. I don't know the square root of 3 over here, so it stays the same. So this is how we are going to simplify these radicals. All right, this is how we're going to simplify these radicals. All right, let's do another one. Let's go from your book. Let's go number 26. 26. All right, using the same technique, let's go with the square root of 40. All right, I'm still looking at perfect squares. So when I break these down, I'm still looking at perfect squares because my index is 2. So you always look at your index. So 40, I always start with the bigger numbers. 36, nope. 25, I can't divide it by 25, nope. 16, nope. 9, can't divide it by 9, nope. 4, ding, 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 ding. There we go. There's our winner. So 4 times what is 40? Bam, 10. And now we have a winner. Square root of 4, 2. Square root of 10, can't do it. Cannot do it. So that's where it stands. And this is what some people are thinking. I'm going to write it down just because they're thinking it. You don't copy this down. All right. This is what some folks are thinking. Well, you could break 10 down into 5 and 2. Yes, you can. But, you heard that? Someone had an idea. But, do you know the square root of 5? No, you do not. Do you know the square root of 2? No, you do not. So this doesn't help us at all. Okay? So that's why we only use, let me get rid of all this. This is why we only use perfect squares like 4, because we want to simplify. All right, let's take this a step further. Let's go with number 32. number 32. So we're going to get the cube root. So now we're going to cube root of negative 32 x squared y cubed. All right. Oh, it sounds like the elota man is passing by. All right. So what we're going to do is now I'm looking for, look at my index. My index is 3. So I'm looking for perfect, I'm coming, perfect cubes. Perfect cubes. All right. All right, so I got my list of perfect cubes. So let me go ahead and box this in. I'm looking at this list. These are all my perfect cubes. All right. And so what I want to do is I don't see 32 there. So I need to ask myself, what can I divide 32 by from this list? I can't divide it by 27, but there we go. I could divide it by 8. So let me go ahead and do that. So we're going to use the same exact technique. I'm going to break this down into 2 radicals, and all the perfect cubes are going to go in this first radical. The remaining factors go inside the second radical. So go ahead and write that down. Everything that's perfect goes in this first radical. All the remaining factors go in the second radical. All right, so 32, we said we're going to divide that by 8. But I'm going to make it negative 8 because I know the cube root of negative 8. It's negative 2. X squared, when you're looking at exponents, what we said is we're always going to divide the exponent by our index. But I can't divide 2 by this 3. So therefore, I'm going to leave it inside of my radical. This one, let me look at this next exponent, y cubed. Am I going to be able to divide this 3 by this 3? Yeah, so let me go ahead and stick it here. And because I can simplify it, it is considered to be perfect, right? Y cubed is perfect because I'm going to be able to simplify it. So let me go ahead and now let me simplify everything. The cube root of negative 8, boom, negative 2. The cube root of y cubed is just going to be y because all we said we're going to do is you divide the exponent by the index. Let me repeat that. You divide the exponent by the index. You never divide the coefficient. You always only divide the exponents by the index. So if you want, you could put a 1 there if that helps you. You don't need to. And these other factors, you're never going to be able to break them down. So all we do is go ahead and bring that down for the ride. All right, so that's how we simplify those. All right, let's do another one. Let me go backwards here. Let me go hit number 30. All right, so let's do another cube root since I have my chart with me. And let's go with the cube root of 250x cubed. 250x cubed. All right, so I want to get in these good habits. I want to have my perfect roots and my remaining factors right there. So everything that's perfect right here, all the remaining factors right here. So 250, let me go here to my list of perfect cubes, and I ask myself, 250, can I divide it by 216? Nope. Can I divide it by 125? There we go. And again, you're just doing this in the calculator real fast. So yeah, that's 125 times 2, right? 125 times 2, that gives me this 250. Perfect. What do you notice about this x cubed? Are you going to be able to divide that 3 by the index? Absolutely. So what that means is that is perfect. So the x cubed goes here because we will be able to simplify that. All right, so let's simplify. What is the cube root? The cube root of 125. What times what times what? It's 125. Check out this chart. This chart is money. I go to 125, bam, I go over and it tells me, oh, 5 is the cube root of 125. Yeah, you like that, don't you? Boom. So it's just 5. Let me just show you how this chart works again. Let's say I wanted the square root of 9, so I go to the perfect squares, square root of 9, bam, 3. Or if I want a square root of 49, bam, 7. If I wanted perfect cubes, the cube root of 216, go all the way to the end, boom, is x. Or sorry, the x value is 6. So the cube root of 216, I go all the way to the end, is 6. So hopefully that makes sense of how this chart works. The cube root of 27, go all the way over, boom, 3. Again, this chart, in my opinion, is very helpful. What did we say we do when you have an exponent? Divide it by the index. So you take that 3, divide it by, boom, that 3. So you're left with x to the first power. You don't need that 1, but just for the sake of our notes, so you see where did that 1 come from. All right. And then this last piece, we couldn't do anything with it, so I just copied it down. So there's an answer. You don't have to write down that 1, but I just want to, for the sake of your notes, where did that come from? All right, so hopefully this video was helpful. Let's take a look at some more examples here.